Yeah, thanks everyone for coming out. This is the Northwest Green Homes Tour. This session is being recorded. So if you don't want to share your voice or image, you can type in the chat bar. Let's see. So yeah, we want to thank our sponsors, Green Home Solutions, Dunn Lumber, Pathway Design and Construction, Mighty House Construction, King County Green Tools, and 475 High Performance Building Supply. So yeah, we're talking about a remodel I did on my own personal house in North Seattle. And we used the passive house principles to kind of guide some of our decisions. So, you know, these are the five. So I'll go through what we did. So no thermal bridging. We did a layer of continuous insulation around the foundation, which is a slab on grade. So we dug down a couple feet and got as much insulation as we could, or covered as much as we could with 2 layers.
Editors.
4 inches of 2 inches of insulation. And then so superior windows is another passive house principle. So where we had operable windows, we changed those to operable triple pane windows. So here we have you can see on the right, it's a window that opens. It's what they call a tilt turn window. So it opens like a door and then it tilts up at the top, so you can let some ventilation in. The windows are, and then where we had fixed windows, so some big windows, we went with the Indo windows. So it's an interior storm window that would cover over the existing window and essentially make it from double pane to triple pane. And then mechanical ventilation, we went with a Lunos fan. So it'll give us heat recovery ventilation. It's a pair of fans. It works well in remodel applications. So you just create 2 holes in different rooms, and then a wire in between them to get the fans to connect. And so the idea is one fan will be exhausting while the other is bringing air into the house. And the one that's exhausting will exhaust through the ceramic core and heat that up. And then when it switches directions in 70 seconds, you'll be heating the other ceramic core and bringing air in through the opening through the heated ceramic core. So then quality insulation, we added 3 inches of Gutex insulation. So it's a low carbon. It actually stores carbon because it's made of plant fiber. So that insulates the walls. It's vapor open, so moisture can escape. And airtight construction. So we want a house that any air coming in comes in through the Lunos fans, and then we want to seal it up everywhere else. So on the right, there's a picture of we used a specialized paint that integrates or spans from the wood wall down to the foundation, and from there that air barrier transitions to that house wrap. So that it can continue the air barrier all the way up. So right now we haven't remodeled the roof, but when we do remodel the roof, we'll be able to tie in to that vento and bring that up and over the new roof structure when we get to that phase of the project. Yeah, so that's that. Does anyone have any questions?
Yeah, you mentioned that your house was a slab foundation. What about a more traditional foundation with a basement, unfinished basement, perhaps?
Yeah, so with the unfinished basement, we can kind of do a couple things. We can define where our thermal barrier is, right? If you're not spending a lot of time in the basement, maybe you don't want to heat it, so that thermal barrier could go on the floor of on the underside of the main floor. If you were using the basement, then we would want that thermal and air barrier to go along the walls of the basement. But we're doing a passive house right now where it's an existing foundation, and the passive house starts at the floor joists up. So we didn't, you don't have to enclose that whole basement and make it part of the passive house envelope. You can kind of work from wherever, and that's a strategy they use in even in like multifamily buildings, so sometimes the multifamily building, there'll be a stair structure, and that will be outside of the envelope, or elevator might be considered outside of the envelope. So yeah, we can really define it wherever. Same with the attic, right? We could do the thermal barrier could be the lid of the drywall, or it could be the peak of the roof. Yeah. So in our house, we didn't have a lot of room for insulation. We can't get under the slab, obviously. So we have just a thin click together flooring, and that can be removed at some point, and insulation can be put down, and then the flooring can be put back on. I'm just waiting to find kind of the right product, because like ideally it would be 4 inches of EPS foam with 2 layers of 1/2-inch plywood crisscrossed on it, but that raises my floor 5 inches, and I don't want to do that. So I'm, I just need to, that'll be another phase of the project where maybe there's an amazing liquid applied insulation, or something that's 1/2 inch tall that I can, that's dense enough that the flooring can just go right back on top of it. So yeah, the slab is definitely gonna always be the weak point. So I did some woofy modeling on the house, and it said I would have to put like 4 inches of insulation down to kind of reach passive house standards.
So you didn't like jack up the house somehow and put stuff under it. You just kind of went with what you could get to above on the walls and the ceiling.
Yeah, we went down the plane of the wall. So if there was a footing, we dug down, to the kind of the base of that footing and insulated along the base. But most of the house was just a slab. So there was no footing. It was a 1947 build. So it looked like, there was maybe an addition put on the front where they did a footing for whatever reason, and then there's a footing in the back of the house. But so we just kind of did as much as we could. But it's definitely helped. It's a lot more comfortable in winter.
Sorry, a flicker just landed on our hummingbird feeder.
Which is right outside our kitchen window. So it's like about 3 feet away from us. Spectacular bird, so close up.
Yeah.
Yeah. I had a question. How would you insulate? We have an old-fashioned single slab garage door. It's a single sheet of plywood. How would you handle that?
Yeah, so I think that one of the one of the important parts is kind of having a good air seal.
Oh,
Right?
you were able to do that.
If
iPad doesn't have it. Mobile has it.
So yeah, if you were able to kind of add some insulation, but also kind of create a better air seal against the where the door meets the door frame. So it could be something that kind of compresses, because air leakage is probably, you know, a major contributor to feeling cold in that area. Yeah.
Thank you.
Yeah.
Anything else?
Well, with insulation, slab insulation, like, you know, a sheet that you would get and maybe glue to some. I worry about fire and off-gassing in a fire. Is there an insulation product that's less toxic when burned?
Yeah, well, I mean, the Gutex is, because it's just wood, but it does, you know, it's not, it's just wood and wax, so but it burns, you know, definitely burns if you put it on a campfire, you know.
Yeah. Oh yeah, sure.
It doesn't seem to be like, you know, I've kind of grazed it with a blowtorch just to see, you know, but it's not going to go up in flames that easily, but you know, it won't off gas.
And what is the name of that product?
Yeah, what is that product again?
It's called Gutex. So that's what we used on the exterior
Gutex?
insulation.
Gutex.
Gutex. Are you planning a remodel, Chuck and Benny?
No, we just have an old house. You know, we just did a sump pump project, so that's our project for the moment. And now we're going to do some electrical, but we have an earthquake retrofit in our basement that would need to be worked around in terms of putting insulation in the walls. I'm not sure how that would work, given the nails every 8 inches on studs. It would probably have to go on top of that.
Yeah. Yeah, it would probably go on top of that. And you said it's an unfinished basement?
Yeah, unfinished.
Yeah. But we use it a lot, actually.
We use it a lot. It's our laundry room, it's our pantry, it's our workshop. It's, you know.
Oh, okay.
It's in use.
Yeah.
It needs to be heated because that's where all the pipes are for the upstairs too.
Right. So are the pipes run through the floor joists above them?
They do. Yeah, and that's not sheathed in plywood. So the joists are open.
Yeah, so you could still kind of tackle it by insulating against the joists and then just assume that it's not going to get that much warmer down there, which would, you know, be kind of quicker and easier and likely cheaper. You know, so then you still kind of have it might end up being warmer down there, but it wouldn't be like drastic, you know, but add some ease. It would also reduce some headroom though. So I don't know what you know, playing with those kind of variables.
Right. And we have some old windows that are not old, they're like 25 years old, that have seals, broken seals that need to be replaced. And so if you have a local or in the area manufacturer recommendation, that would be helpful.
For what was that?
Windows. We have 3 giant picture windows out front that used to be 3 separate windows each. And their seals have failed. So they're not cloudy, but there's some patterning on the inside that you can't get out. So we would like to replace them with windows that open. I liked your tilt and, what was it called? Tilt and
turn, yeah.
Tilt and turn, and that's a European window thing with the Euroclimb.
Yep. Yeah.
That's a great idea.
Yeah. Let's see. Yeah, so Dave, the filters are hardwired, but you just have to wire one of them. So I don't know if you can see here, they're in this room. But basically, there's a wire that runs from here to supply power to here, and then low voltage that runs all the way over to the one in the other room. So we didn't have to run a lot of, Romex or anything, but it's just a low voltage speaker wire, 3-strand, 18 wire. So yeah, I don't know that there are any that are battery powered, but that would be a good idea. But I think that, hey, Alan. Yeah, I think that they do a great job and they don't draw a ton of electricity. So, yeah.
Carlisle Classic Homes, are you going to be repeating the presentation that you did earlier, or are you wrapped up?
We just finished, so answering some questions, and then I'll start the video that I have.
Oh.
Yeah, but basically, and we can just talk more in general and see if other things come up. But yeah, Alan. So what we did is we have a small single-story house in North Seattle, and we added the Gutex insulation to the walls of it. So 3 inches of Gutex, and then we added 4 inches of XPS against the foundation footings, cut off any thermal bridges from front and back patio, and insulated behind those, and then replaced the operable windows with triple pane tilt turn windows, and for the non-operable windows, we added a Indo window on the inside. So they were double pane windows, and then we added the Indo. So, and then even our kitchen door has a triple pane window in it. So all the windows were upgraded.
Wow. Interesting. Yeah.
Yeah. So Dave, yeah, the Indo windows, it's an interior storm window. We're the local dealer for them, so I've installed like 1,600 of those panels. Really no condensation issues from that. In fact, what they often do is eliminate condensation. Because we had double pane windows, we never had any condensation. But on a single pane window, I have experience with them kind of reducing or eliminating the condensation in that window. So yeah, they're custom made. We have that one window that's an octagon, and so we're able to kind of measure the octagon template and send it down to they're made in Portland. So then they, made us that custom shape octagon. So, yeah. Have you used those before, Alan?
Pardon?
Have you used the Indo windows before?
I got a presentation on them by a nice young lady, but I've never actually used them. I've been talking about, upgrading single pane windows in some historic classic homes in Seattle. And the people are telling me they like the idea, but they do not want to let go of their window because of that melted shimmer quality.
Oh, yeah.
And then I didn't know what to say, but then a friend said, we put a storm on the outside. And then I thought about the Indos as another option. If you want to put something on the inside rather than the outside. I'm glad to know you're the dealer up here.
Yeah, so with the storm on the outside, those, like Dave was asking about condensation, like you might get condensation on the outside, but they're designed to drain out, on that plane. So exterior storm windows are designed to drain, which means they have holes. They're not designed to be kind of a airtight layer. They're not going to have a ton of airflow, but it's going to be warmer if you put the storm window on the interior of the house. So, and the
I see. So that's a selling point for the Indo.
yeah, and it's just easier, access is easier. But yeah, we've done a lot of historic older homes, where people want to kind of retain that look. So yeah, it works great. And yeah, like I said, for our house, we wanted to kind of be as cost and carbon and comfort conscious as we could. So taking out our big 8-foot by 5-foot, double pane window and reinstalling it, and then adding the Indo, made a lot of sense. So
Nice. So this is your home?
this is my home. Yeah.
Nice. Tell me a little bit about Gutex. It has a reputation as being expensive.
Yeah, I mean, I think that there's a lot of quality to it that I kind of didn't expect. You think you're just buying these wood fiber boards, but the tongue and groove nature of it adds just a ton of value in my mind. I didn't expect to appreciate that as much as I did. So you get that bottom course started, and then they just kind of stack on top of each other. So you're gonna add a rain screen over top anyway, and that's gonna further kind of hold them in rock solid. But with the so you can set your bottom course with 2 cabinet screws holding that panel up, and then every panel above it just 1 cabinet screw, because you're just kind of temporarily holding it in place. And then the way I do it is then I wrap the Mento over it really tight, so that holds it all together. And then the rain screen goes on with the screws going through it that likely is going to penetrate each of those panels. So yeah, it's not inexpensive, and the other thing that I really like about it is it's pretty firm. So I know with rock wool, where you have some compression, a lot of builders will get those kind of specialized screws that will kind of hold themselves kind of rigidly, knowing that the rock wool insulation isn't very rigid. So there's kind of specialty tools for that. Whereas this, you just tighten the rain screen tight to the Gutex, and it's not gonna suck in. The wall's gonna be as straight as it was gonna be otherwise. No, we can do the video. Yeah. Hi, I'm Brian Cowan, building performance specialist and carpenter at Carlisle Classic Homes. We've lived in North Seattle for a couple years now in this house, and when the siding needed to be replaced, we decided to do a deep energy retrofit. Our project included new windows, new doors, exterior insulation, new siding, new heating system, and new hot water system. I would like to show you more about that project.
So before doing our home energy retrofit, many of our friends would come over and put large jackets on when they would visit us in our house, especially in our living room, because this is the coldest corner of the house. We often couldn't successfully grow houseplants in this area because the heat from the furnace wasn't even, and it didn't heat this part of the house as well. After doing the retrofit, by adding exterior insulation not only on the walls, but retrofitting the windows to make a double pane window, a triple pane window essentially with a plastic insert, this portion of the house is now cozy and can support growing plants in the winter, as you can see.
So as part of our remodel, we did new siding. We went with hardy lap siding for durability. We did it over a 3/4 inch rain screen, which will help the hardy material dry out, be more durable, help the paint last longer. We had a old cedar siding in place that was past its useful life, so the necessary upgrade was kind of rolled into the effort put towards the project. So one of the philosophies that we wanted to keep in mind with the remodel was the passive house principles, and one of those is thermal bridge free construction. So we wanted to insulate as much as we can so we don't have heat loss to the outside. So what we did is we added 4 inches of EPS foam in 2 layers to the foundation. So that required us to put in a lot of extra effort to cut back the porch, the front porch and back porch, and some other areas. But the extra effort should help us improve comfort. So our wall assembly is made of Gutex insulation, and that's a wood fiber product that has sequestered carbon in it. The wall itself is existing shiplap with 2 layers of the Gutex insulation on top of that. Outboard of that with staggered seams. The tongue and groove nature of the Gutex promotes air tightness, but then our primary air barrier is a layer of Mento 1000, which is wrapped over the outside. And the Mento 1000 is a vapor open, almost like a Gore-Tex material. And then outside of that we have our rain screen and our hardy siding. So one component of the house I was very excited to upgrade were the windows. So where we had large fixed windows, we upgraded those with Indo windows to create a triple pane effect. And where we had operable windows, we had replaced those with triple pane tilt turn windows. So these windows give us the option to open the window entirely for egress or for more ventilation. But then we also have the option to tilt the window in for security and ventilation at the same time. The other ventilation strategy we have is a Lunos fan. So it's a pair of heat recovery ventilation fans that will continually supply our house with fresh air. This is important because we've built the house with the Mento membrane to be very airtight. So all of our fresh air in the house, instead of coming from unintentional leaks and gaps in the foundation and walls, all of our fresh air comes filtered through the fans that are paired up between this room and another bedroom. And that system is very easy to install. It's just a matter of selecting an appropriate spot, making the hole, and running low volt wires between the pair of fans. It also has filtration, so for improved air quality, we can change out and clean filters to improve the constant supply of fresh air that we have intentionally delivered to our house. We're here on the outside of the house, and here's our ventilation port for our Lunos fan. The Lunos fan is our primary ventilation strategy. The Lunos fan is a pair of these that slide into tubes. There's a ceramic grate in them that will transfer heat efficiently when we're cycling between flowing in and out as the fans do. They also filter the air through this MERV 5 filter, which is great for summertime smoke or any other pollen or allergens. And here we've run the fan through a block, which helps integrate with our rain screen and allows us to have a nice flashing detail to deal with any bulk water or water vapor that's behind the cladding. So a main goal in reducing the carbon footprint of this remodel was to decommission our gas heating system. So we had a 95% efficient gas furnace that had ducts that ran to each of the individual rooms. And because of the increase in insulation value, our house is very comfortable with a single head heat pump coming from one location. This is able to serve most of the house directly, and the other rooms are not uncomfortable themselves. So with the 3 inches of insulation, and then here we have an window insert over the existing double pane window. So we have a big triple pane window, and we've reduced the heat loss through that, and that gives us enough efficiency that the heat pump is able to adequately keep us comfortable throughout the winter. So our goal with this project was to focus on the thermal performance between the top of the top plate and the bottom of the foundation wall. So we focused on adding insulation along the side of the house. Because we're a slab on grade, we don't have as many easy options to insulate the slab, and added insulation under the existing floor might come at a later phase. Our next phase would be to plan a remodel for the roof. So that might involve trusses and definitely a conditioned roof. So a non-ventilated roof assembly that will put our insulation barrier near the peak of the roof, which will give us more insulated living space, as well as air tightness to kind of encapsulate the whole house. So right now we've only focused on the walls, and then next summer we'll focus on that roof area to complete it, and then the cherry on top will be solar panels down the road. One thing we liked about this house when we bought it was the big southern facing windows in great locations, and we wanted to retain both the location and the light coming in, but improve upon it. So what we were able to do is remove the big picture windows and then reinstall them with some details that will improve drainage and efficiency. And then within those window openings, we were able to add acrylic Indo windows. So those will provide another pane of window, making it essentially triple pane and giving us a lot more comfort sitting in our corner of the house, sitting at our dining room table. It really makes the room a lot more cozy.
The one thing about older homes is that sometimes they have really neat features that you want to keep even though you're doing a retrofit. An example here is our octagonal window that many of our neighbors recognize and point out that they like as part of a feature of our home. So Indo Windows is an interior storm window that allows you to essentially make your double pane window a triple pane. So this is a neat way to keep that feature in your home. So the feature of the home stays, but with this insert, you get the benefit of better energy economy.
So this corner of the house was always pretty cold. We had a thermal bridge from the patio connecting to the slab foundation, and we had a corner which has a lot more surface area. So by improving the wall insulation, adding insulation below the concrete to provide thermal break, and then replacing the door. So the door gave us an opportunity to improve the R value significantly. We had a single pane window in the old door, and we upgraded to a door with a triple pane window. So a total of R5 for this door, which is a major improvement over the single pane window that we had before, and it's allowed us to have a lot more comfort in the kitchen, primarily in this corner. To improve resiliency, we also put a metal pan that the door is set into, So just to help shed any water and build a more resilient door. So this corner of the house is now much improved through the energy retrofit, and time in the kitchen is a lot more comfortable.
So while our home energy retrofit improved the comfort of our home, we are also interested in seeing whether it improved the cost, improved our cost savings in terms of our utilities, as well as our emitted CO2 in terms of the use of those utilities. So we looked at our historical data of our gas and electricity bills over time, starting from 2017. And we can see that things change after our initial demo in April of 2019, followed by replacing our gas furnace, installing an electric water heater, installing a heat pump, and then ending here in April with us working from home a lot more due to COVID. You can see that it's rather difficult to compare these numbers because the gas bills come every month, whereas the electricity bills come every 2 months. We can compare these on a quarterly basis, however, and we see that in Q1 of 2020, we did see a drop in our total utility bills. However, in the last quarter of 2019, which is when the retrofit was really first completed, we didn't necessarily see a big change in that particular quarter. In addition to cost, emissions of CO2 are interesting. We converted our energy usage of gas and electricity to emissions of CO2 or expected emissions of CO2 using TerraPass.com for our zip code. And here you see a moving average over time. And in this case, it shows us that converting from gas to electricity alone was really not enough to cut carbon emissions. And so we're really looking forward to using the fact that we're all on electricity at this point to enable us to move to solar in the future to reduce those CO2 emissions.
Okay. Any questions, Alan? Any other questions?
Well, congratulations on a very thorough retrofit given the constraints, you know. You know, no one has the money to just do everything all at once.
Yeah.
And, you know, sometimes people argue, well, if you insulate, the benefit of going to a better window is sort of marginal or minimal. But here where your focus is on the wall, clearly it was a huge upgrade, huge saving, and huge improvement to get those triple pane or create triple pane windows. So I really like that.
Yeah, and I think like with the wall, like 3 inches of insulation is a little bit on the extreme side, but it goes on just as fast. The second layer goes on probably quicker, and it's all carbon storing material. So there's a plus side, even if it's, you know, even if we're kind of out in the diminishing returns of every inch of insulation you add, it kind of, you know, it's not as important. That next layer might not be as important to emissions as it is to just carbon sequestration. And I'm sure it, you know, in the end it has added benefit of the comfort. I mean, the comfort is just incredible.
Yeah, that was very evident, and it's kind of encouraging that you can get these big benefits even if you're, you know, sort of not doing everything all at once.
Yeah.
Sometimes we feel kind of oppressed by that, but by doing some really good things, you get big benefits. It's I think it's just a great example of that.
So sorry, I jumped in the middle.
No
so
problem.
You may have covered this, but presumably you have a 2x4 wall cavity and 3 inches of insulation. Walk me through that.
Yeah, so we have so we kept the walls insulated. The walls were filled with cellulose, and there are a couple spots where we did pretty much everything from the exterior. So we needed new siding was kind of the part of the impetus, right? But we did everything from the exterior. So we got down to the shiplap that was under there, and then outboard of that we added the 3 inches of insulation, and then our weather barrier, and then a rain screen, and then siding. So the wall is like 9 inches thick, I think, at this point. So yeah, well beyond yeah.
And you said from outside in, correct?
Yeah. So we were working on the exterior of the house. So from the exterior of the house, we made the exterior even bigger with the insulation, and then the weather barrier, and then the cladding and siding, or the main screen and siding.
Thank you.
Yeah.
So Brian, did the thickening of a wall, that must have reduced your roof overhang, right?
Yeah, it did, and that's kind of the next step, is to figure out what we're gonna do with the roof.
Okay.
So that's kind of the next phase, is to either go up a story or do a truss that gives us some attic space, because we have attic up there now, but it would be nice to have a little more access. So need to working on a design for that and seeing what we come up with. But yeah, so then we'll just pull off the top few courses of siding. We have that weather barrier kind of stapled and taped to the to like above the top plates. We'll just pull that back, and then we'll start, we can go up from there. So it's all phased to it's not completed in the way you would complete it if you were stopping. I mean, I can do that by making soffits and stuff to make it all look good, but for now it's phased to go beyond.
But at least you had enough overhang that the gutters weren't impinged by fattening the wall.
Right. No, we probably have a 12-inch overhang at this point still. So yeah, it's
great.
Yeah, that was super handy. Yeah, because that did allow us to do.
Because there's some of those World War II houses that have almost no overhang, and you can't really keep fattening from the outside, or you're gonna just kill the gutter.
Yeah, we have a hip roof on the front, and then a gable roof on the back. So the gable roof does have an overhang, and that's all exposed. So what we did is temporarily we padded out that upper attic wall and covered it with like Tyvek, or a low, with a house wrap. So it's in the back of the house, so no one but our neighbors sees it, and it's like protected, and I can disassemble it and reuse all those materials when we do the
nice.
Or if I had to, I could just go out there and finish siding it, and it would look finished, But so yeah, we're it was definitely something to puzzle through, and it would be more challenging if the roof wasn't so forgiving. But yeah, that back part, we had to put in some extra effort on to make it look reasonable. But yeah, so
yeah, I think that going above and beyond standard construction it's just a lot of problem solving one after the next, and really appreciate what you did, and how you were able to keep overcoming the challenges and come up with a great package. It's very impressive.
Thanks. Yeah, we learned a lot, and actually as a company we're working on our third project with the Gutex. So we've I've had a lot of opportunities to see it from, new construction to we're doing another remodel right now with it. So it's a great product for that.
Good. Well, Carlisle's really come onto my radar.
Awesome.
And pushing ahead, and appreciate you guys. Thank you so much. I'm going to
Yeah.
take off now, but great seeing you.
Yeah, you too. See you, Alan.
Yeah.
It looks like it's just you and me right now. Once maybe one more person comes, we'll start it up. But
All right.
it's been weird. I talked with George and John yesterday. They, you get like 180 people signing up to view your house, and then it's like it's just you and me.
Yeah, I had a good chat with them yesterday. We're talking about their HRV system because of
Yeah.
COVID. I was saying, how do you isolate people from COVID? And they kind of
like quarantining it in the house, you mean?
Yes, exactly.
Yeah.
And I kind of yesterday was a real eye opener for me because I've been grappling with this problem. Is how do you do, I'm into co-housing, right? So if you got a lot of people living in the same structure, how do you protect them?
Yeah.
And I realized after talking to them that it's probably the HRV system because it's basically fresh air constantly flowing through the house.
Yeah.
You never really recirculate that air.
No, but I guess you're not mixing it. Yeah, that's true. Yeah.
I mean, right now, the air exhausts through the bathroom, but it goes back into releasing its energy to another side of the building.
Right.
It's like most systems, they come on and they're distributing heat, right? They're not a true ventilation. They're doing double duty. They're distributing heat, but they're also doing ventilation. But if you can separate the ventilation from the heat, then you can solve the COVID problem.
Yeah.
With the HRV.
Yeah, and it's we were talking the other day just about like people managing big buildings and how they're like, yeah, they probably like the only lever they have is like change the filter more often, right? So they can do that, but that's like, you don't have a system that you're even able to dial that much. It's kind of like it's on, off, change filter. Those are the only controls you have. So.
Right. The Solus project, if you ever have a chance to look at that project, that's exactly what they did. And so because they're an ERV system, they're promoting that feature as the healthiest building.
Right.
It's like the first or the largest passive house, residential passive house, but also the healthiest.
Yeah.
Because basically people are living in fresh air, and even fresher than fresh air because they go through the filter.
Yeah. Yeah, and especially now with the smoke, like having the Lunos fans alone, like it's just, I mean, we really are, especially in these like stay-at-home times, I feel like we're really enjoying the benefits of all the work that was done with the retrofit,
Yeah. So what did your ventilation system turn out to be? How did you did redo that, right?
So it's just the Lunos fans, right? Have you seen Lunos fans?
I don't think I've seen it, but I've heard about them.
Yeah, so it's just right here. So this.
Okay. So it's connected to the outdoors right there. Right?
Yeah. So it's connected right there. And then there's another one in our bedroom. So they'll go, one will go in and one will go out. And the one that's going out is going through like a ceramic core, and it's heating that up. And then after 70 seconds, they'll switch directions. So again, not a true HRV, or I guess our system doesn't have, you're still mixing the air, right? Like if I have COVID, or if there's something in the house that I don't want in the house, it's still getting kind of ping-ponged around.
Right. But it's for a retrofit, it's perfect because you're not having to. You can still get the benefit of the energy savings because both systems are exchanging energy, right? It's just the direction is changing and so is it coordinated automatically?
Yeah, they're wired together, so they just switch after 70 seconds. But what some people do for multifamily or co-housing is just a pair of these per resident, so then your air is mixing, but just within your residence. It would be transferring my air with no one else. So that's an option too, and it would give a little more control. Not that you need that much. Like they have a couple settings, and we usually run it on low. I think I kicked it up to medium the other day, but just, I'm going to wait a week and then see what the filter looks like, because I know I'm supposed to change the filters, but I just blew it out with a air compressor and put it back in. So after a week, I'm going to check and see how smoky it looks.
Is it washable?
I don't think it is. Yeah.
Mm-hmm. And how much are those units?
It's like $1,000 for the pair. So, but that's with all the, all the components and stuff. You just need to get 18 gauge 3-strand wire and run it between the two. So we have one in this room and the controls in this room, and then one in our bedroom. So
in a way, you can isolate with two Luna systems.
Yeah, you could zone them too, and so that's what we do in bigger buildings, where we'll have like the living room might be a pair, the master bedroom might be like a pair, one in a closet and one in the bedroom. So you make these zones, but it's not the same as like an ERV would be. So
right.
Yeah, it's an interesting discussion. Looks like George just joined us. George, we're talking about COVID and ventilation and multifamily co-housing buildings. So where the Lunos might be good like per unit, but the there are maybe better strategies with a full ventilation system.
But basically, you're talking about $1,000 per space, which is pretty cheap compared to putting in a fully ERV system.
Yeah.
And but how does that screw up your blower door test?
Oh, you tape them off, because they would be, there's not a true hole in the building.
Yeah.
So, like right now, it doesn't act as a hole in the building. So I don't want to kind of take credit for it as a hole in the building. So you just tape over it with blue tape.
Interesting.
Yeah.
On your heating system, is that a like a mini split?
Yeah. It's just a ductless mini split on the wall. So, and it's just in our living room, but it has, it's the Mitsubishi model that has the heat sensor. So it'll kind of sense the temperature all around the living room, and then it can also shoot straight into our bedroom. But in general, like the house is not cold even in the bathroom, which is 20 feet away behind another wall. You know, the heat seems to mix pretty evenly, and I think that because it'll direct the heat in, you know, whatever wherever it seems like it needs it the most. So it seems to do a really good job of getting it to that area, and then having the Lunos fans to kind of mix more air seems to help as well. So, but yeah, we're not sure what we're going to do with the second story, but you know, probably have some kind of unit up there. So we weren't sure like if we would need to add another one downstairs, but I don't think we will. You know, I think it'll be sufficient for this floor, and then maybe we need to add one upstairs when we complete that phase, or maybe not. Maybe this will take care of most of the heating. So
Now, is your Lunos a through wall or a central system?
it's a through wall.
So how many did you do?
Just one pair.
Okay.
So it's a little undersized, but again, we might tap into more of a HRV system when we do the upstairs. So have ventilation that supplies either a second story or a kind of a attic space, conditioned attic space, you know, depending on what we decide to do with the design. But then that also might be able to supplement some, that HRV would also kind of maybe cover the living room. So right now the Lunos fan just goes in a bedroom and an office, and it mixes pretty well between them, but you know, it's not going to mix through the whole house. So the second phase will kind of tie some of these pieces together by adding that ventilation as well.
And so you kept your inside face of all the drywall consistent and just remodeled from the outside, essentially?
Yeah. Yep. So we did a earthquake retrofit with, because we're slab on grade, so just with Titan screws. So in a couple areas, we opened up the bays from the outside, and then put a Titan screw through the bottom plate into the concrete. And then we would kind of cut back further so that we could kind of install a full sheet of plywood. Because right now it's just shiplap, so that would give it more shear. So there were a couple areas where we were just like, oh, let's put a sheet of plywood there. There hasn't been one in a while, or oh, we should add, you know, some bolts there. So we also changed some interior wiring and some plumbing. We ran some like, you know, hose bibs to places that would be more convenient. But yeah, we were able to do kind of accomplish a ton of things without having to do a lot of interior drywall modification. There were even a couple windows that we reframed or relocated or resized, and that we were able to do with, you know, limited interior damage. So
Yeah, that's how I learned to do a buck out.
mm-hmm.
That's great.
Yeah.
On your Lunos, if you don't mind, did you investigate any other system? Like Panasonic I believe it. Yeah, well, it has it's ducted, right? So you could have ducts from coming in from one side and blowing out the other side.
Yeah.
But it's a single room unit.
Yeah, and I didn't do much research, you know, kind of bought into the whole kind of 475 kit, right? And that's kind of like, you know, so there was kind of like some cost savings by buying like that much of a package. And we had done we had some exposure to those, but since I've done mine, we've done probably like 6 or 8 at work, you know, just because they're a great strategy for retrofits or new construction. Because there's just not it's so tough with like open floor plans with new construction or remodels. You know, our house didn't become more open, but we didn't want to run any ducts up through the attic because we don't know what the attic is going to be. You know, I'm going to tear the roof off, and then I might want a floor joist to go where a duct run is, you know. So we wanted something where it doesn't really attach or run anywhere up there. So
Right.
yeah.
Did you do a blower door test on the house after you finished?
Yeah, I did. So I will tell you, it's actually not that much tighter because we're still connected to the attic, right? So we've done some things like build those boxes over can lights and stuff, but there's a lot of areas up there where I just haven't focused on yet. So the blower door test ended up being somewhat like maybe 20% better than what it was before. But that's because it's all leaking through the ceiling. I can tell you that we don't feel any drafts because there's just, you know, the air is just the only place it's leaking is up high, right? There's just not coming in and creating a draft. So the house like doesn't have any drafts because we're basically air sealed from the top plate down, but it still unfortunately is somewhat leaky. But we'll attach all this all together when we do the roof modifications. Hi,
So
John.
hi, John. How did you go about prioritizing this first major step versus those others? I mean, I just personally right now I'm kind of in analysis paralysis with our own 1954 home, and it's almost like I know that it's like a sweater unraveling. As soon as I touch one little corner, I just feel like it's going to open so many financially unfeasible cans of worms that I'm not quite sure which project to tackle first. So how did you guys prioritize the scope of work that you just completed versus those other things that you want to do?
Yeah, so tying into those other things we want to do, we want to tear our garage down and build a whole new house there, or as like an ADU from scratch, right? So when you think about the priorities of all the things we wanted to do, this was kind of a good starter project. Yeah, so there is kind of, I don't know, in our case, like if we want to redo the roof and we don't know how we're going to do it yet, whether it's trusses, I need to figure out a structural plan, right? So I need to like hire a structural engineer and see what I can and can't do before I go far down the road of designing it and figuring out what I want and what I can have. But I knew that it would kind of end at the top plate, you know, and then maybe we have to disassemble. I mean, I'm sure that we'll have to disassemble some of this for the expansion, right? Just to tie walls together and stuff. But this seemed like, and we also kind of wanted it to be, you know, we don't have any plans of moving, but I kind of wanted to have a situation where the house could be sellable, or it didn't look like something that was like half completed.
Hey, is your goal to be a net zero house eventually?
Yeah, definitely. You know, solar will be kind of after we finish the roof. So yeah, I think we Michelle did some analysis of the bills, and unfortunately we haven't seen the major efficiency or major drop in usage because all of a sudden, we're home more often and for longer. So our electricity use has actually increased since we've completed the remodel, but that's because of COVID and being working from home in some cases.
Oh, the Lunos little fan filters, what level of filtration are they, and do they have any charcoal filter involved with them?
It's a MERV 5, and it's just a mesh filter, so I'm pretty sure that they don't have any charcoal component to them.
Okay, can you upgrade them, or is that really what they're limited to?
I didn't see an option to upgrade them, but maybe there is that I'm not aware of.
Okay.
But just like looking at buying new filters, I think I just saw the standard type of filter that I
Sure.
have already. Yeah.
Okay.
Yeah, so the monitoring system is just our utility bills, but Michelle did some kind of advanced analysis of that. So that's where we got a lot of those pretty graphs that she supplied. Okay, so where did I get the tilt turn windows? They're from a company in Poland called Geisler, and I got them through a local company called Euroclimb. And Euroclimb is on Aurora Avenue. But yeah, they import them from there. So then the quality insulation. So we have the foundation insulation you can see at the bottom on the right with some flashing over it, and then above that is the Gutex insulation. So Gutex is a wood fiber insulation, so it's storing carbon in it, so it's sequestered carbon, and so it also has a tongue and groove to it, so it fits together nicely, adds air tightness, and then it also is easy to kind of stack and build with because of those tongue and grooves. So the Gutex is comes from we ordered that from 475 Building Supply, and it's shipped from Europe to Portland. There's a local kind of hub there in Portland, and they can get it to us pretty quickly by the pallet. So it's not you do have to buy it by the pallet, so it's not readily available in that sense, but it's about a week to get it, which is if they have it in stock, which is a pretty good lead time for a specialty product like that. But yeah, and then there are some companies that are planning on building that in the US, doing that process in the US. And I think their kind of plan is to start in Maine, and then there's talk of doing it in the Pacific Northwest. So, I don't know what, I think it's like more of a birch-based wood. So I don't know what we're harvesting here and how our, cedar and stuff can be used as building materials, but the local tree speciation might be a factor too with how locally we can get the product.
I think you mentioned another product too that you used as a rain barrier, or
yeah, so the Mento 1000 is also from 475. So that's like a Gore-Tex style material. So that is vapor open, but it's airtight. So with passive house or what they call low load buildings, the heating load isn't really high, So like an inefficient house would have a lot of BTUs running through the wall to dry it out. In my house, it's just a heat pump and it's not on most of the time. So for my wall to dry out, the assembly, the way it's arranged, kind of supports and encourages that. So vapor will kind of move to the Gutex and then escape like it would through a Gore-Tex jacket. And water won't come back in, but the vapor can go out. And having that rain screen space behind the siding kind of creates an air channel where air is always kind of rising, that will further kind of draw out that vapor and get rid of it. Or if bulk water comes in, it can just drain right down that channel as well, because it's open on the top and bottom to let water vapor out or liquid water or air. So yeah, and they have all kinds of tapes and stuff. It works really well.
Okay, good, thanks.
Yeah, and that's about it. But it was a fun project, and appreciate everyone stopping by to see it. So have a great rest of your day. Cheers.